Okay, so I did the modern geometric proof of proving that two sides of a triangle added together, the length of them is greater than the sum of the third side. So what the proof is in your geometry textbook in high school is that you're given a triangle ABC, and you have to prove three things: that the side AB plus BC is greater than the side AC, that the side AB plus AC is greater than BC, and that AC plus BC is greater than AB, i.e. the sum of each of the two sides is greater than the third remaining side. So what the proof does is it starts with a theorem, and it says let ABC be a triangle. So you have A, B, and C, where AB is the longest side. Then your first is that since AB is the longest side, you know that AB is greater than the side AC, because it's the longest side and therefore is greater than any of the other sides. Thus, AB plus BC is greater than AC, because if this is larger than AC already, then adding anything to, sorry, that's my teammate, adding anything to the largest side is always still going to be greater. And by the same logic, we also know that AB is greater than BC, thus AB plus AC is greater than BC, from the same logic as above. So you have this. I'm going to erase up here. So now you know we have to prove that third theorem that we're still stuck with, which is that AC plus BC is greater than AB. And we can't just derive that from anything down here because AB is the longest side. So now we have to figure out that some combination of AC plus BC will be greater. So what the geometry book then does is to draw a line, CZ, that is perpendicular to the line AB in the triangle. So then what you do is you draw a line down here, and that becomes, you set this to be Z. You have a line running perpendicular. So by theorem 3.9 in the textbook, which is through a point outside of a line, there exists exactly one line that is perpendicular. So we know that this is the only perpendicular line that can exist in the triangle. And then there's a corollary that comes also in the textbook that says that the perpendicular segment from a point to a line, so we know that CZ is the shortest segment from the point to the line, i.e. there's not a line that you can make from C to line AB that is any shorter than the perpendicular line that already exists. So therefore, we know that AZ is the shortest segment from A to CZ. And then we also know then that if this is the shortest line, this is going to be the shortest segment from A to CZ. And then we also know that BZ will also be the shortest segment, so then is also the shortest. From E to segment CZ. Thus, we know that, we'll go back up here. This is what my math homework looks like. We know that AC plus AZ, or AC is greater than AZ, because we established that this is the shortest line that can exist there, and BC is greater than BZ. And then that means that AZ plus BC is greater than AZ plus BZ, because we take two things that we know are greater than AZ and BZ, so these are two larger numbers, and we'd add them, and they would still be larger than the combination of the two smaller numbers. And therefore, AZ plus BZ is the exact same line as AB. So then we know that AC plus BC is greater than line AB. So then we have proven 1, and we have proven 2, and we have proven 3. Thus, every line, or every addition of two sides of a triangle will always be greater than the length of the third side.